oldest civilizations in the world, the Indian civilization has a strong tradition of science and technology. Ancient India was a land of sages and seers, as well as a land of scholars and scientists. Research has shown that from making the best steel in the world to teaching the world to count, India was actively contributing to the field of science and technology centuries long before modern laboratories were set up. Many theories and techniques discovered by the ancient Indians have created and strengthened the fundamentals of modern science and technology. While some of these groundbreaking contributions have been acknowledged, some are still unknown to the most.
Excavations at Harappan sites have yielded rulers or linear measures made from ivory and shell. Marked out in minute subdivisions with amazing accuracy, the calibrations correspond closely with the hasta increments of 13 by 8 inches, traditionally used in the ancient architecture of South India. Ancient bricks found at the excavation sites have dimensions that correspond to the units of these.
Binary numbers is the basic language in which computer programs are written. Binary basically refers to a set of two numbers 1 and 0, the combination of which are called as bits and bytes. The binary number system was first described by the Vedic scholar Pingala in his book Chandra Shastra, which is the earliest known Sanskrit treatise on prosody, which the study of poetic meter.
Indians, as early as 500 BCE, had devised a system of different symbols for every number from 1 to 9. This notation system was adopted by the Arabs, who called it the Hind numerals. Centuries later, this notation system was adopted by the Western world, who called them the Arabic numerals as it reached them through the Arab trade.
The Fibonacci numbers and their sequence first appear in Indian mathematics as Matramir, mentioned by Pingal in connection with the Sanskrit tradition of prosody. Later on, the methods of formation of these numbers were given by mathematicians Viranka, Gopal and Hemchandra. Much before Italian mathematician Fibonacci introduced the fascinating sequence to Western European mathematics.
The Chakravarti method is a cyclic algorithm to solve indeterminate quadratic equations, including the Pell's equation. This method for obtaining integer solutions was developed by Brahmagupta, one of the well-known mathematicians of the 7th century CE. Another mathematician, Jayadeva, later generalized this method for a wider range of equations, which was further refined by Bhaskara II in his Bijganit theory.
I am Harshi and I have my friend Rashi Shah with me. Today is 22nd December, which in India is celebrated as a National Mathematics Day. We celebrate this day to thank and appreciate the contribution of Srinivasa Ramanujan in the field of mathematics. Now my friend Rashi Shah would like to continue.
Mathematician Ramanujan didn't have any close friends, and someone asked him the reason. He replied that although he wanted to have close friends, but nobody was up to his expectations.
When pressed how he expected his friends to be, he replied, like numbers 220 and 284.
The person got confused and asked, "What is the connection between friendship and these numbers?"
Ramanujan asked him to find the divisor of each number. With much difficulty, the person derived and lists them as 220, 1, 2, 4, 5, 10, 11, 20, 22, 44, 55, 110, and 220 itself. The divisors of 284 were 1, 2, 4, 71, 142, and 284 itself. Ramanujan then asked the person to exclude the numbers 220 and 284 and asked the sum of the remaining divisors. The person was astonished to find 220, 1 plus 2 plus 4 plus 5 plus 10 plus 11 plus 20 plus 22 plus 44 plus 55 and plus 110, and it is equal to 284. One plus 2 plus 4 plus 71 plus 142 is equal to 220.
Ramanujan explained that an ideal friendship should be like these numbers, to complement each other even when one is absent. The other friend should represent the friend.
Now I would like to continue. India has given birth to many of the greatest mathematicians, such as Aryabhatta, Brahmagupta, Ramanujan, Bhaskara, etc. Maths is a scoring subject for 10th and 12th standard point of view. Maths does not need mugging up. It only needs logical thinking and all concepts to be clear. Many students have mathematical anxiety. The main reason of getting this condition is because we fix it in our mind that mathematics is hard. So, to get rid of it, we need to change our thoughts about maths and see it from a better perspective. Thank you.
Hello friends, today I Ritanshwar from class 8A with some mathematical help will guess the day and the month of your birthday. So let's go. So please follow the directions carefully. If you want, you can also use a calculator. So let's go. Step 1. Choose your birthday and multiply it by the number 2. For example, if you were born on July 12th, multiply 12 by 2. Step 2. Add 5 to your total. Then step 3. Multiply your total by 50. Step 4. Now add the month of your birth to the total you got. For example, if you were born in June, add 6, or if you were born in July, add 7. So step 5. Finally, subtract 250 from your resulting total. Now, you should only be left with either a 4 or a 3-digit number. So, the incredible result is that the last 2-digit number is equal to the month of your birth, and the remaining digits at the beginning will be the day of your birthday. So, did it work for you?
Myself, Krushi Shah from 7th A. Today I am going to talk about perfect squares and their geometrical representations. A perfect square is a number from the given number system that can be expressed as a square of the number from the number system. 25 and 5 are both natural numbers. 25 can be expressed as 5 into 5. Thus, 25 is a perfect square of 5. Coming to its geometrical approach, let us take a square of 5 cm each side and divide it into 5 equal parts vertically and horizontally. Count the small squares. There are 25 squares of same size. Therefore, 25 is a perfect square of 5. You can try this with 9, 4 or any other perfect square. Thank you.
Hey Abhyani, haven't the maths homework that you gave yesterday of learning tables?
Yeah, I have learned all the tables.
So, which is the easiest table that you find?
I think 11 is the most easiest table.
So now, tell me, what is 11 into 17?
I don't know. I have learned till 11 into 10 only.
So now, I'll tell you a trick that would multiply any 2-digit number with 11 fractions of seconds.
I would love to know that too.
So now, let's begin with the trick. You can take any 2-digit number to multiply by 11. I've taken 25. So now, what we'll do is make 3 blanks. And just write
2 in the hundreds place and 5 in the units place. Now we'll do sum of 2 plus 5, which is equal to 7. So we'll just put 7 in the tens place. So the final answer is 11 into 25 is equal to 275. Now, I hope you would be able to calculate 11 into 17.
Yes, I will be able to solve 11 into 17 in fraction of seconds.
So now, you can tell me the answer.
The answer is 187. Before showing me this trick here. Good morning teachers and my dear friends. My name is Kavya Mandwagela from the class 5th day, and today I am going to be showing you an easy math trick for how to solve 2-digit number tables in an easier way. This trick was performed by a famous Vedic mathematician Shri Bharatiya Krishna Tirthaji. For example, the table of 87. First we have to separate the 2 digits to 8 and 7. Then we have to write down the table of 8. 8 1s are 8, 8 2s are 16, 8 3s are 24, 8 4s are 32 and 8 5s are 40 and so on. Then we have to write down the table of 7 beside it. 7 1s are 7, 7 2s are 14, 7 3s are 21, 7 4s are 28, 7 5s are 35 and so on. Then we have to take the number 16 from the 8th table and the 10th place of the 7th table, which is 16 and 1, and we have to add those 2 digits, which is 16 plus 1, which gives us 17. And then the 17 we get, then the remaining number, which is 4, we have to take that number and put it in the units place of the number. Then the answer that we get is 174. So 87 2s is 174. And like this, we can keep continuing this process again and again. And this is how we can write any 2-digit number table in an easier way. Thank you.
Hello everyone, my name is Arnav Sangli and I am going to present you some math tricks. For the first trick, we need to draw a 3x3 grid. In that grid, we first have to write down 1, 2, 3, 4, 5, 6, 7, 8 and 9. For the second step, we just have to write down 0, 1, 2, 2, 3, 4, 4, 5, 6. We just have to write down these numbers in the tens place of these numbers. After some time, you will realize that this is actually the table of 7. As you can see, all the numbers above actually indicate their position in the table of 7. You can find out any number in this. Now moving forward to the second trick. In the second trick, we use this to multiply a 3-digit number by a single-digit one. To solve this, we first look at these numbers. As per this is 3, then I drew 3 vertical lines, 1, 2 and 3. As now this is 1, I just drew 1 vertical line. This is 2, so same for this also. After that, I look at this number. I draw horizontal lines as per the number. Now, in my case, this is 3. I drew 3 horizontal lines. 1, 2, 3. Now, for the last step, we just count all the places where the 2 lines joined. So, in the first place, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So, I wrote down 9 over here. In the second place, 1, 2 and 3. Then I wrote down 3 over here. Same for the third one. 1, 2, 3, 4, 5 and 6. So, I wrote down 6. Here, I am taking the number as 312 multiplied by 3. Now, to continue this trick, we need to draw vertical lines as per the numbers. In this place, hundreds place, we have 3 over here. So, we need to draw 3 vertical lines like this. 1, 2 and 3. Now we have to do the same with the next number. In my case it is 1. So I just have to draw a single line. The next number is 2. So I have to draw 2 vertical lines. Now the next number is 3. So we have to draw horizontal lines as per the single number. In my case it is 3. So I will draw 3 horizontal lines. 1, 2, 3. Now we have to count the joints forming this number over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here I can find 9 joints. The next 1, 2, 3. I can just find 3 in this. The next one is 1, 2, 3, 4, 5, 6. So here we have our answer. The answer is 936. And this trick only works for certain numbers. The third trick is for multiplication of 2-digit numbers. This trick is used when both of the numbers contain 1 in the tens place. For the first step, we need to add this number to the whole number over here. In my case, this would be 2 plus 14. I have the answer as 16, which are my first 2 digits of my answer. The third step is we have to multiply both of the units place numbers. Now 4 multiplied by 12, 2 is 8. So my answer is 168.
First equation. There are 2 solutions. How can you make the equation true by moving only one matchstick? 1. First, this I will take, and here it will be 0. 0 plus 4 is equal to 4. Second solution, here I will take this stick and I will here 9. So 4 will become 9. 5 plus 4 is equal to 9. Riddle 2. How many total squares are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. And here this will be 10th, 11th, 12th, 13th, and this whole one is 14. This is a parking lot, and which number is under this car? So this is 16, 6, 68, 88 and 98. But you do like this way. So it is 86, 87, 88, 89, 90 and 98.